I am Anil Kumar. Welcome to my series on quadratic functions. Now we will discuss about inverse of quadratic functions. So basically, inverse of a quadratic function will undo what the function has done. Let's try to understand this particular statement. So let's say this is the box which is doing the operation of quadratic function. That is to say that we place some inputs here. Right, so we have some inputs, and for each input we'll have an output. Now since we are talking about quadratic functions, we'll say this relation here for the function is y equals to x squared, where x is the input and y is the output, correct? So I hope you're getting the idea. So that is what this function is doing, a quadratic function. So what we could do here is that we could place some inputs. Let's say if I write down a number which is starting with, let's say 2. We'll take smaller numbers. So if 2 goes in, what comes out is square of 2. So we get 4 as our answer. Now if 1 goes in, then what comes out is 1 square, which is 1, correct? Now if 0 goes in, what comes out is 0 square, which is 0 itself. Okay, now if I feed in a number which is, let us say, minus. So if minus 1 goes in, then what comes out? Square of minus 1 minus 1 square is positive 1. So we get again 1. And what happens if minus 2 goes in? So if minus 2 goes in, we get square of minus 2, which is equal to 4. So that is what our quadratic function is doing. It squares all these numbers and gives us something which is always positive. Correct. Now, what do you expect from the inverse of this? So this is the function we are saying. This is what we call f of x. Now we have the reverse operation. That is to say, we want something which will reverse its operation. We write it as f minus 1. So like it's inverse. F of minus 1. This is called inverse. So we say inverse of f of x. Now what we want here is that we want to feed in the numbers which we got, and we want to get what we had fed. So the idea here is now we want to feed in 4, and what we expect is a number which we entered. So for 4, we really entered 2. So that is what we expect from this, right? So this reverse operation. So we are just saying this reverse operation. Is what inverse function is. So that is what inverse of quadratic function is. Perfect. Now here is a problem. When I enter 4, I might get 2, or I might also get minus 2. You see that since minus 2 also resulted into 4. So there is a confusion whether I should get 2 or minus 2. So since this is a confusion, in this case, f inverse is not a function. Perfect. And that happens with even 1. So if I feed in 1 here, then I could get 1 as an output, or I could get minus 1, since minus 1 also resulted into 1. So that's the tricky part. So whenever we are working with quadratic functions, what we notice here is that when we feed in the values, we may not get the actual value which was the cause of that value, right? Now, only for one value it works. In this case, it is 0. If I feed in 0, we know we are going to get out 0. That is fine. But with all of the numbers, we found that there are more than one values, 2 in fact. So, for the quadratic function, what we realize that the reverse of the operation gives us 2 values. So now, when we reverse this operation, we get 2 values, so it is not a function. However, there are techniques to make this a function, and that is to restrict inputs, right? So first thing which we notice, that reverse operation can be performed. However, it is not a function but a relation. So this is only a relation. And mathematically, algebraically, this relation is written as f inverse. We don't write x here since it is not a function, is equals to plus and minus square root of x. So we get 2 values, plus and minus, as you can see. So we can always write a relation which is inverse of the quadratic function. So in this particular case, the relation is f inverse equals to plus minus square root of x. Now we'll learn the techniques to make this a function, and the technique is to restrict domain. So in this case, we could work with 2 types of domain. One, we could say, well, let x be greater than equal to 0. That could be case 1, for example. Or we could say, let x be less than equal to 0. That could be case 2. So doing this restriction, we know that we can get exactly what we fed. So if I only consider positive values, in that case we are sure that inverse has to return the positive value. That is to say, it is going to work with the upper half. Let's say these values. So in that case, we are sure that inverse of 4 will be 2, inverse of 1 will be 1, for 0 will be 0, since we are only working with half of these values. You get an idea. So what we have understood here is that inverse of a quadratic function is not a function, it is a relation which could be shown as f inverse equals the square root of x with plus and minus values. To make it a function, we can restrict the domain. If you restrict the domain as x is greater than equal to 0, you will be returned with positive values. If you restrict the domain to x less than equal to 0, you will be returned with negative values, since less than equal to 0 means 0 and the negative values. So I hope that part is clear. Now let's move forward and look into the graph of function, the quadratic function and its inverse. So we just learned a very important part of inverse of quadratic function, and that is inverse of quadratic function is not a function. And we also learned that we can restrict its domain to make inverse a function. Perfect. Now let's begin from here. Now let's talk about algebraic solutions, right? And also graphical representation. So we'll begin with the very basic function, the parent function y equals to x squared. So y equals to x squared is a quadratic function. We need to find inverse of this particular function. And let's do it using a graph. So in a graph, I could always sketch the function y equals to x squared. Let me show it here. So it's a parabola which is kind of like this. So let's write down some coordinate points on this parabola. So we can just make a table of values here. It's always a good idea to work with table of values. So this point here is 0, 0. Then as we move forward, we have here point 1 and 1. 1 square is 1. Then at 2, let's say we have another point here, which is 2 and 4. 2 square is 4. So we'll just take 5 points. So if I do minus 1, I again get 1 here. And for minus 2, we get square as 4. Right? So these are the values for y equals to x squared. Now what happens when we reverse? So when we say inverse, that means in inverse we kind of go in a different direction like this. So from output, this is y, the output, input x, we from output try to get the input. Do you get the idea? So the inverse will be, let's flip these values. We get 4 minus 2. We get 1 minus 1. 0, 0 remains. 1, 1 is invariant. It doesn't change. And here we get 4 and 2. So that becomes the inverse operation. Correct? So what you notice here for the inverse, that there is a point which is not changing. 1, 1. So this point remains. There's another point which is not changing, which is 0, 0. That also remains. So if I connect these points, what I get is kind of a square root function here, and it is similar on this side. It's symmetric about the x-axis this time, right? Since you are getting plus and minus values along with, for the same inputs. So that becomes the inverse. So this is the inverse. So graphically, what you notice here is that if the function f of x is parabola which opens up, then the inverse, which we designate like this, inverse is again a parabola which opens on the right side. So we get a parabola which opens right side horizontally. Do you see that part? Correct? Now you could actually work with many different kinds of functions. You will notice that if you are working with a parabola which opens downwards, for example, then its inverse will be another parabola which is going to open towards the left. Do you see that part? So if you have that the function f of x is a parabola which opens down, then the inverse will be a parabola which opens left. Do you get this idea, right? And we also learned about some points which are common, right? So the common points are called invariant points. Invariant. They do not change. For example, these two are invariant points in case of a function. Perfect. So from the parent function, we have learned that inverse function changes the shape towards, rather the direction. Shape remains almost same, but the direction changes. Now, graphically, you could also sketch this function by reflecting it on the line y equals 2x. Right? So you could get the same result by reflecting graph on line y equals to x. Correct? You could also get the same result by swapping coordinates, which we have shown here. So this part here shown is by swapping coordinates. We got the new coordinates, and then from there we sketched our inverse function. So what you learn now here is that algebraically you could actually calculate the value of inverse function by reversing the coordinates. Graphically, you could reflect it on line y equals to x. And what you also notice is that a parabola which opens up, the inverse of that is a parabola which opens to the right. And inverse is not a function, since if I draw a vertical line, then the inverse, it crosses at 2 points. If you see the graph of f of x, if I draw a horizontal line, it crosses at 2 points. So from here, by inspection, we can say inverse is not a function. We call this as a horizontal line test. Which is, if you draw a horizontal line through the function f of x and it intersects at more than 1 point, then inverse is not a function. Perfect. So with this, discuss how to find inverse of a quadratic function when the graph is given to us. So the question here is to sketch inverse and write its equation. Second part of this question is, how can the domain be restricted for inverse to be a function? So the graph over here is a parabola which opens upwards. It has vertex at a point which I could write here as, let's write down here, vertex is at a point which is 3, 2. So this is 3 and that is 2. Now we also see that there are two invariant points. So we have sketched a line which is y equals to x. The line crosses the parabola at 2 points, and these 2 points are invariant points. So let me write these two as shown here as invariant points. That means these 2 points will be common on the function as well as the inverse of its function, right? To sketch the inverse of a function, we have to reflect on y equals to x. So the idea here is to reflect the function f of x on the line y equals to x, right? So that is kind of a mirror image. So whenever this reflection is done, what happens? The xy points swap, so they become yx. So the vertex on the function f of x will now change to the vertex which will be 2, 3, correct? As you can see here, this is a parabola which opens up. So when you do inverse, then it will open right. Okay. So this point here, which was at 3, 2, will now be at 2, 3. So this point changes to that point on the inverse function. So in black ink, we are showing the points and data for the inverse function. So we got our vertex. Now if you see, this parabola moves 1 unit as you move up and right, correct? So from here, it moves 1. So we have 2 arms opening towards, when I say opens right, it really means the inverse is going to be kind of like this. So we can follow these steps. So we have steps from here 1, and next time 3. So we go 1, 2, and 3. Similarly, because of the symmetry, from here we get 1, and then next time we get the step 1, 2, and 3. So you have a part of the parabola right there. So it kind of goes like this. So that is the inverse of the given function. Do you see that part? So it is that easy. Now the second part to this is, now let's also write down the equations. So here is how we will write equations. Now let's look into the equation part. Since the steps we'll go with the steps. Steps are 1, 3, 5, 7. We know the value of a is 1, and therefore the function f of x could now be written as, with the vertex as 3, 2, x minus 3 whole square plus 2. It opens upwards. Now as far as the inverse goes, so for the inverse function, so f inverse, I'm not writing x since it is not a function, right? So the inverse of this is the vertex changes, right? So it's a square root function, which we write with plus and minus. Now these values swap. Do you get the idea? 2 and 3. That is one way of looking into it. Second way is you could work reverse order. So x minus 2. So we're doing, first we do minus 2, right? And then we do square root with plus and minus, and then we add 3. Then we add 3. So that is how you get inverse functions equation. So we got the second part now, which is writing equation. Is that clear? Now the third part to this is, how can domain be restricted for inverse to be a function? Now to restrict the domain of the function, we have to see one arm only, since it fails horizontal line test, right? So if I draw a horizontal line, let us say like this line crosses at 2 points. If I restrict my domain to, let's say, one side of the parabola, so let me restrict this domain to x values which are greater than equal to 3. In that case, we'll get the inverse of upper arm, which is this arm. You see that? So in that case, our inverse will be a function. So I'm writing x here now, whose equation will be positive x minus 2 plus 3. Does it make sense to you? You could also restrict this domain to the left side. That is to say, case 2. This is, we'll say now case 2. What you could do is, you could take x values which are less than equal to the axis, which is at x equals to 3. In that case, we are talking about the left side of the parabola, which is this part. Then the inverse of the function is going to be negative square root of x minus 2 plus 3. Do you see that? Which is the lower part of the parabola, which opens upwards. So if you do this, then what you get inverse function as this part. And if you take the right side, then the inverse function is the upper part of the parabola. So I hope that gives you a lot of insight of how to sketch the inverse of a parabola, the quadratic function, from the graph directly. Also, how to write their equations, restrict domain to ensure that inverse is a function. Perfect. Now, here is another question for you. Treat that as a test question. Try to answer it yourself. Now, I hope you got all the concepts. Treat this question as your test question. What you need to do is sketch inverse and write equations. So write equations for both the function itself and also its inverse. Here is the graph for you. The parabola represents the function, right? So this parabola is the function. Here we have sketched a line which is y equals to x. you could always reflect this parabola on the line, get your inverse. Once you do that, then after that, how can the domain be restricted for inverse to be a function? That means domain restriction for the function, which will result into inverse as a function. That's the second part of this question. I hope the concepts are clear to you. Feel free to pause the video now, write down your answers, and then check with my solution. Correct. So from our observation, what do we get? We have the function f of x whose vertex is at the point. So vertex is a very critical point. It is at -1, 6. And this parabola opens down. So the inverse will be what? So the inverse will have a vertex. Swap this 6 minus 1, and it will open in which direction? Since it is opening down, it will open left. What I'm trying to say is that it's going to open in this direction. From the vertex, which now will be 6 minus 1. So 6 minus 1 is right there. So from this point, we are expecting the parabola to open in this direction, towards the left side. Correct? Now let's look into these steps. So the first step is 2 down. So that means we are now going through these steps, which are 2 times 1, 3, 5, 7, and so on. That means a value is 2. Perfect. So from here, go 1 and 2 down. So from here, go 1 and 2 down. We are now making a parabola which will open left. And second step will be 2 times 3, which is 6. Second step, 1, 2, 3, 4, 5, 6. Then from symmetry, you know the other point is right there. And then it will be 10, right? Moving further ahead. Now joining these points, I could always sketch my parabola, right? So this is a smooth curve which kind of goes like this. Do you see that? And these are your invariant points. So you could move your curve through these invariant points. So that is how, that is how we could actually sketch it. So that becomes the inverse of our function. And clearly, this is not a function, since if I draw a vertical line, it intersects at 2 points. So it is not a function. Correct? So we have sketched the inverse of the function. Now we are going to write its equation. So as far as the function goes, for the function, the equation will be, so f of x is equal to, we know 2 and it is opening downwards, so it is -2. Vertex is at -1 and 6, that means x plus 1 whole square plus 6. As far as inverse is concerned, f inverse will be, so what you should do is within square root, we've swapped, right? So we have to solve for x. So first you take away 6, which is x minus 6. Then you divide by -2. And then you square root, reverse calculation. Whenever you square root, you have to write plus and minus, and then you take away 1. So that becomes the inverse. Clearly, the vertex is at 6 minus 1. 6 minus 1. Do you see that part? You will also notice that in these cases, domain and range has swapped. Correct? So in the first case, we have x value, which belongs to all real numbers, right? And in the second case, we have the x value, which should be greater than equal to 6. Correct? Less than equal to 6, right? Negative, because this negative is going to make it positive. Okay, so what happens really? In the first case, we know x belongs to real numbers. However, y is less, the range y is less than equal to 6. So in the second case, they change. So what happens here is that x now is less than equal to 6 and y belongs to real numbers for the inverse. So that is the domain and range for the inverse. Perfect. So we got the equation, domain, range for both. Now, what we are going to do is to state restrictions. So we'll do the part 2 now. How can the domain be restricted? Now, domain can always be restricted by taking one side of this parabola from the vertex. So we could have two cases. So let's say case 1, we could do that x is greater than equal to minus 1. In that case, we have the upper half. So if I take x as greater than equal to minus 1, we get this parabola on the right side, and as far as the inverse go, we'll have the parabola moving left upper half. So here we'll have this parabola as our inverse. Do you see that? So the inverse will now be a function, so I'm writing with f inverse x, which will be equal to the positive value of x minus 6 over minus 2 minus 1. Does it make sense to you? Correct? Now, let's take case 2. So case 2 could be when x is less than equal to minus 1. So now we are looking into the left side of this parabola. Clear? In that case, the inverse of our function will be equal to the negative value of square root of x minus 6 minus 2 divided by minus 1. That means the lower half. Is that clear? So in this fashion, you could actually sketch inverse of a quadratic function very easily, write its domain and range, and also see how to restrict domain of the function to ensure that inverse is a function. So we could have two cases as we just discussed. Either side of the axis of symmetry. So the idea is to look for axis of symmetry. Now we will take a couple of examples and see how to find inverse of a quadratic function. So the question here is that we are given a function f of x equals to 5x squared plus 20x plus 20. We need to determine inverse and its domain and range. So let's begin with the function itself. F of x equal to 5x squared plus 20x plus 20. We could write f of x as y. So we have y equals to 5x squared plus 20x plus 20. To find the inverse, what should we do? So to find inverse, we have to swap x and y, right, to find inverse. That is the first step. And then second step is to solve for y. So it always involves these two steps, right? So step 1 and 2. So let's do that. Swap x and y really means instead of y, I will write x, and instead of x, I will write y. So we get 5y squared plus 20y plus 20. Now to solve for y, what should I do? Well, you learned in quadratics that we could complete the squares. So we have to complete the squares, which we could by factoring out 5 from the first two terms. So 5 times 4 is 20, 4y plus 20. Now we'll do half of 4, add and subtract its square. Correct. So we have here 4y. Half of 4 is 2. So we'll add and subtract 2 square. So that gives you a perfect square. Y plus 2 whole square, right? And minus 2 square is minus 4 plus 20. Now we can open the bracket. So we get 5 times y plus 2 whole square minus 20 plus 20. Well, they cancel away. So we get 5 times y plus 2 whole square. So we get our quadratic equation. Now let's work with this quadratic equation. So we have here x equals to 5 times y plus 2 whole square. Now let us see how to isolate y. So first step, divide by 5. So we get x over 5 equals to y plus 2 whole square. Now square root. So when you square root, you get square root of x divided by 5. Don't forget to put plus and minus both. So we get y plus 2 equals to plus minus square root of x over 5. Now you can easily isolate y. It becomes equal to x over 5 square root with positive negative minus 2, that is y. So we can write that the inverse of our function is plus minus square root x over 5 minus 2. Does make sense to you? So that is how you could get inverse of your function. Perfect. So we have done the first part, which is to determine the inverse. And now let us look into domain and range. Okay. So for domain and range, let's begin with the function itself. I could write this function f of x as equal to 5 times, we completed the square, so we know it is x plus 2 whole square, right? So that was the function in vertex form. Now that helps to write domain and range. So the domain for the function, as you know, for real of all parabolas is x belongs to real numbers. The range is restricted and the range is y belongs to real numbers. In this case, y is positive. It is a parabola which opens upwards and the vertex is at minus 2, 0, right? So this particular parabola, let me sketch it here. Okay, so we are going to sketch the function which is kind of like this. I'm sorry. Not this, but I'm so sorry. The vertex is at minus 2, right? X plus 2 means move 2 units to, so this is y equals to x squared. So it moves like this, and that is your function. At minus 2, we have the vertex. So this is the function f of x. Parabola shifted 2 units to the left with the vertex at minus 2, correct? As far as the inverse is concerned, what do we have for that? Now we did get the expression for inverse, which is f inverse of the function is these values changes, right? So the inverse was plus minus square root of x over 5 minus 2, correct? So in this particular case, the domain has now become what was the range, correct? So it is x belongs to real numbers where x is greater than equal to 0. Do you see that? Now that makes sense. Within the square root, you cannot have the negative number. So it is greater than equal to 0. As far as the range is concerned, for the inverse of the function, it will be all real numbers. Correct? Well, so that is how you get domain and range. As an extension, sometimes you may be asked to restrict domain and range so that the inverse is a function. Perfect. So that could be an additional thing. Now, as an exercise, I would like you to, so the question for you is to sketch inverse of f of x, correct? So that could be your exercise. Remember, it is a parabola which opens towards the right. Is it okay? The points will swap. This point, which is at minus 2, 0, will now be at this point, right? And now you can sketch a parabola opening left from here. So let this be your exercise. Let's move on and take another example to see how to find algebraically the inverse of a given function. We are almost at the end of our video. We will now discuss how to determine inverse of f of x, which is equal to 5 times x minus 2 whole square minus 3 for x less than equal to 2. So in this case, the domain of your function is restricted, and now inverse could be a function. So let's figure it out. We are given the function f of x equal to 5 times x minus 2 whole square minus 3, and we are also given that the domain is restricted and is less than equal to 2. Now x equals to 2 is axis of symmetry, right? As you can see here, the vertex is at 2 minus 3, and this is a parabola which opens upwards. Okay, so that is what is given to you. To find inverse, we'll first write the equation in the term of y and x, which is 5 times x minus 2 whole square minus 3 is equal to y. Second step is to swap. So now we will swap x and y, right? So we'll swap. That is to say, we'll write x for y and y for x. Now we'll solve for y. So bringing 3 to this side, we get x plus 3 equals to 5 times y minus 2 whole square. Divide by 5, we get x plus 3. Divide by 5 equals to y minus 2 whole square. Now we'll square root. And remember, whenever you square root, what should you do? You should always take both positive and negative, right? Y minus 2. And now you can isolate y, which is equal to plus minus square root of x plus 3 divided by 5 plus 2. So we get the inverse. Now, did we miss something from here? I think we did. We were given the function that the domain is restricted to less than 2. It means what? It really means that we are talking about a parabola which is opening upwards, whose vertex is at 2 minus 3. When we say that we are looking into only one part of it, less than 2, we are actually looking only to the left side of the parabola. Correct? So, since it opens upward, we are looking for a solution which is inverse, and inverse will be the bottom half of your parabola going right. Correct? So that means this inverse should have a restriction. Correct? So we cannot use plus and minus. So what should we do? So let me make this correction now and rewrite this as what? So we'll write the inverse is for us a function where we are going to take only the negative value, which is negative square root of x plus 3 over 5 plus 2. So that portion which starts from the vertex, which is, you have to swap these values, correct? Which is minus 3, 2. You get the idea, correct? So it makes sense. Only the right side from this vertex, parabola opening right, lower part. So it's the lower half of the parabola which opens right, which is the inverse, and that is a function. Do you see that? So that is where we are going to end it. So when you do square root, in this case, do not take the positive part, only take negative part, since we are working on a restricted domain where x is less than equal to 2. That is to say, we are looking into this side of the parabola only. And it passes a horizontal line test. Therefore, its inverse is also a function, and that function will have unique value 1 to 1 for all the inputs. So this is where we end, and I hope you understand and appreciate how we can find inverse of a quadratic function in different ways. How restricting a quadratic function ensures that inverse is also a function. Feel free to write your comments and share your views. I hope this was useful for you. If you share, like, and subscribe to my videos, that will be good. Thanks for watching and all the best.